I think everyone kind of knows it, but still, what is time series? Anyone? It is basically data points collected or recorded over time, right? That's why it is called time series, right? So basically, if we are interested to see how a variable changes over time, then we work on time series data, right? Yes or no? I have given some of the examples that we frequently use. Say, for example, in finance domain, we often work on stock price, right? It is obviously a time series data, right? Exchange rates, any market indices. These are all examples of the inflation, right? Interest rate. So these are all examples of time series, right? GDP, frequently used in economics, related research. We use unemployment rate. These are all time series. So time series is basically a sequence of data points collected or recorded at successive points in time, typically at regular intervals, right? So how many of you have written any research paper on time series? Is there anyone who has already got some of your works published on time series? Anyone present in among these 15 members? Is there anyone who has already kind of published some work on time series? Yes? Okay, no issues. If you have not done, not to worry, because that is the ultimate objective that we should all work towards, right? Okay, just someone please confirm, is this meeting being recorded? Are you able to see that? Yes?
Yes, sir, it is recorded, sir.
Yes,
It has
Yeah.
been
sir.
recorded, sir.
Okay. I just want to double check. Okay, fine. So now let us get into the main discussion. So let us take a look at some of the examples of time series. I have the Excel sheet. I will just show it to you, and we will get back to this data set later on when we will be doing little advanced things. So we have a data set which I will share with all of you, where we have a variable called DPI, that is real disposable personal income, measured in billions of dollars. Obviously, this is taken from US, US economy, right? Gross domestic product, GDP, measured in billions of dollars. Then real personal consumption expenditure, billion of dollars. Corporate profits, billions of dollars. Dividend, billions of dollars. GDP, uh, then disposable personal income, and personal consumption expenditure. These are all in constant dollars here. That means they are expressed in terms of $2,000. So you can multiply whatever is given with $2,000 to get the actual number. Corporate profit and dividends are in nominal dollars. Okay. So if I plot this, these variables after making a log, conversion or log transformation, they will look like this. And you can easily see that all of them are showing upward trend, right? Yes or no? And in fact, in time series analysis, the very first step is to take a look at the plot of the variable that we are planning to work on, right? So if you look at the plot, all of these variables are showing upward trend, right? All of them are showing upward trend. And in economics, or for that matter, even in finance also, this is a common practice to take log, of variables, provided you don't have negative numbers, because you cannot, you know, that is not defined. Log of a negative number is not defined. So if there is no negative number, then we can always go for log transformation. And what is the advantage of log transformation? Anyone? Why do we do log transformation? Someone who attended my last workshop, if you can answer this.
When there is too much fluctuation in the data set, sir, then it like normalizes the data. It brings it in a
Does
normal,
not
like,
normalize the data, but it definitely has some advantages. Anyone? Why do we take log transformation wherever possible? Yes?
To remove the variance from the equations and to remove the heteroscedasticity.
Yes. So, first of all, if you take log transformation, it improves linearity in your data. Okay. So it kind of smoothens the variable, and as someone rightly pointed out, that it might help you to, reduce the heteroscedasticity problem. There is no guarantee about it, but it can definitely help in reducing those issues, right? So it's a common practice to take, log of a variable, provided that variable does not have any negative values, right? So that's what we have done. So these things I will get back to you later. So just to give you basic, or just to get started, that in time series analysis, this is the very first step whenever we work on a time series based variable. We just plot it and take a look at it, how it looks, right? So on the face of it, it seems that these are trending upward, right? Though there are fluctuations in between, but they are trending upwards, right? Now, from this charts, we might be thinking that can we predict or forecast how these variables will behave in future? Is it possible? Looking at their plot over time in past, can you really forecast how these variables are going to, behave in future? Is it possible? Yes or no?
sir.
Yes or no? Is it possible?
Yes, sir, it is possible, sir.
In fact, that is one of the objectives of any time series analysis, because the basic purpose with which this time series analysis started was to do forecasting, right? Yes or no? Was to do forecasting, right? So suppose we want to speculate on the shape of these curves beyond the sample period. So we have a sample period. Beyond that, if you want to, understand how this variable, a particular variable is going to behave, if that is our objective, then it is possible to, make that forecasting, right? We can do that if we know the statistical or stochastic mechanism or the data generating process that generated these curves. That means if we are aware of how these variables have behaved in past, and if you can, unlock that pattern, then we can extrapolate that pattern in future and make use of those patterns in forecasting, right? But before we do that, we first need to understand some of the very, very important concepts, what I call as vocabulary of time series, right? So ultimately, we'll definitely go for some sort of forecasting, and we'll go beyond, much beyond that. But before we get into that, first we need to understand some of the, basic concepts or vocabulary of time series. Okay. So my point was to make you understand that it is possible to do forecasting based on based on the analysis of the past behavior. That is what I'm trying to put across at this point in time. I'm not going to get into forecasting right away, but it is very much possible. But before we jump into forecasting, we first need to understand some of the basic things which we will now delve, delve into. Okay, so what are the things that I'm going to cover in this? First, we are going to talk about what is stochastic process. Stochastic process. Then we will talk about stationarity. We'll talk about purely random processes. We'll talk about non-stationary processes. We'll talk about integrated variables. We'll talk about random walk models. We'll talk about co-integration. We'll talk about deterministic and stochastic trends. And we will talk about unit root change. I won't be able to complete all of these in today's session, but most of the things we will cover. Remaining things we will cover in the next session. But please make sure that you are very comfortable with all of these, because these are the things which will keep coming again and again. And if you are not clear about these concepts, so it will be difficult for you to absorb the advanced concept, right? Okay, so let us start with stochastic process. So what is stochastic process? Have you heard of this term before? I think you have, right? What is stochastic process? What is the meaning of the term stochastic? Anyone? Though it is written on this slide, but if I just ask you, do you know what is the origin of the term stochastic? Anyone? What is the origin of the term stochastic? Forget about the origin. What does it mean in simple words? What does this term stochastic mean? Anyone?
Sir, I was understanding that stochastic is somewhat random, but then the random walk model is written below this.
You are right. So that should not stop you from telling that stochastic means random, right? So okay, that's correct. Stochastic is basically in simple terms it means random, right? But if you want to get little deeper into the origin of this word, it is basically originated from a Greek word called stokos, which means target or bullseye. Now you might be thinking, how is this linked? Now see, I have explained this, how this is connected. So I think you must have played this before, right? Suppose when you throw, darts on a dart board, right? You have a particular, target, that is the bullseye or the target in mind, correct? But how often did you hit that bullseye? Most often you are not able to hit that target. And out of the 100 darts you might, throw, and if you are lucky, you might hit only couple of times or few times. All the other darts will be spread randomly around the bullseye. Okay, are you able to connect how this, bullseye or target is connected with the stochastic or randomness, right? Yes or no? Is it clear? So you try and hit that bullseye, but you end up hitting, not that bullseye, but in and around that bullseye, and that that takes a random, shape, right? So out of 100 darts, you might be lucky to hit the bullseye only a few times. At other times, the dart will be spread randomly around the bullseye, and hence this is the origin. Okay, but to cut the long story short, so stochastic basically means random. So Dr. Amit was right, though he was not very confident about it, but he was right. Stochastic means random. Okay, is it clear, everyone? Yes or no? Yes
Yes, sir.
or no?
Yes, sir. Yes.
Yes,
Okay.
sir.
Now consider for
Sir, I
instance,
think that with this example, we will never forget it.
yeah, you should not forget that was the idea behind it. So stochastic means random. Okay. Now consider for instance the real GDP of USA in 1970 quarter 1 was some 375 9.99 billion approx, right? So this is there in the data set. So I've just taken the number from there. We'll use this data set later on. This I'm just using as an example. So can we really call GDP as a stochastic process? Anyone?
No, sir, it is not random.
It is not random.
No, sir. It can be predicted, like GDP can be predicted. Before the declaration of the GDP, it is already being predicted by the researchers that GDP would be like this. So it is not stochastic.
Now, this is where the cat lies. This is how most of us will tend to think, but it is not like that. See, it is clearly written. In theory, the GDP figure for the first quarter of 1970 could have been any number. Yes or no? It could have been any number. Yes or
Yes,
no?
sir. Yes, sir. Yes, sir.
Depending on the economic and political climate that was prevailing at that point in time, it could have been any number.
Yes, sir.
Yes. The figure that we have quoted in this slide,
yes, sir,
is a particular realization of all such possibilities. There were numerous number of possibilities that GDP could have been, 3758. It could have been 3820. It could have been any number, right? Out
Yes, sir.
of those all numerous possibilities, we have got 3759.997 was the actual realization, right? Therefore, we can say that GDP is a stochastic process. And the actual values that we have observed or that we have captured in our sample are realizations of that particular process. That is the sample. So, in fact, the sample that we have taken is a collection of all the realized values of GDP out of the random process that GDP follows in theory, because GDP can take any value that you cannot tell with certainty, right? So only after you have got the numbers, then you quote that number. But that before that declaration happens, the GDP number could be anything. Yes or no? Is it clear? Yes or no?
Clear, sir.
Yeah. So this distinction between the stochastic process and its realization is akin or similar to the distinction between population and sample in cross-sectional data. So the realizations are the sample, and all the possible values that the GDP could have taken is the population, right? So just as we use sample data to draw inferences from the population, in time series, we use realizations to draw inferences about the underlying stochastic process. Is this point clear to everyone? Yes or no? Is it clear?
Sir, I have a simple doubt, sir. Like
Yeah.
GDP, if you said, since you have said that GDP, its realization, it can be in any value. It is like it doesn't depend on anything. Then how we predict the GDP for, suppose it is for 1970 first quarter? Can't we predict the for
So
the
that is different.
Okay,
We
sir.
predict the GDP based on its future realization, past realization.
Yes, sir. But actual value cannot
But
be predicted.
before, suppose, what will be next year's GDP? Do you know? You do
No,
not
sir.
know,
No,
right?
sir. Yes,
It
yes, I
could
don't
be
know.
any value.
Yes, sir.
Yes or no? So
Yes,
in
sir.
that
Yes, sir.
way, it is random.
Okay,
But
sir.
once that number is declared, then it's a realized value, right?
Okay, sir. Understood.
That
Sir.
is not random. Correct?
Yes, sir.
That's
Yes.
what is being said, right?
Okay,
Okay.
sir. Okay, sir.
So when we work on the realized values, past data, right? That is not random, but GDP can take any value. In that sense, it is random. That is what they are saying. Okay, is it clear? Understood?
Yes, understood, sir.
Okay. So, so this is the point that I was talking about. What is the stochastic process now? we can easily define. It is basically a random process, right? So a random or stochastic process is collection of random variables ordered in time, right? So generally we use these notations. Y in bracket t is used for continuous variables, and Y subscript t is used for time series collected at discrete point in time. So GDP, is it a continuous variable or is it a time series collected in discrete point in time? What is your answer?
Continuous.
So this is another source of confusion most of us have. So in statistical terms, you might think that okay, GDP is a continuous variable. It is not a categorical variable, right? Yes, that is correct. But it is collected at discrete point in time, right? Yes or no? It's not like temperature, correct? Yes or no? You
Yes, sir.
collect GDP at discrete points in time, right? Quarterly, yearly, right? Yes or no?
Yes,
So
sir.
that is why we use the notation YT. That is Y subscript T, not Y in bracket T. Generally, we use Y in bracket T to denote the time series which are continuous in nature, right? Okay. So that's what if we let Y represent GDP for our data, we have Y1, Y2, Y3, then Y242 and Y244. These are different quarters of our sample, right? Where subscript 1 denotes the first observation in our data set, that is GDP for the first quarter of 1947, and subscript 244 denotes the last observation, that is GDP for the fourth quarter of 2007. So we have data from 1947 first quarter till the fourth quarter of 2007. Keep in mind that each of these Y values is a random variable because it could have been any number. Out of those possibilities, only one number we could realize. Okay, that's the point. Okay. So I think now you at least have some basic ideas, uh, especially what is meant by a stochastic process. Now we will come to the most important part in time series, that is called stationary stochastic process. The concept of stationarity. Though it sounds so simple, but it is so confusing. People are thoroughly confused. I have seen people who are thoroughly confused with the concept of stationarity. Right? We'll try and demystify many of those things in this session. Right? So, what is stationarity? Anyone? What is meant by stationarity? What is meant by stationarity?
Any series which are having a constant mean variance and no autocorrelation will be termed as stationary series.
No autocorrelation. That is it the case? You are talking about a special case, that is white noise process. Okay.
Sir,
But if there is
stationary,
autocorrelation, it cannot be stationary.
sir, simply
This-
putting, stationary may be considered as uh, some increase or decrease over the period of time. Means if we are doing the quarterly data analysis on GDP, it may have some kind of a straight line relationship.
Okay. Any other points anyone has? Though
Can
everything is written on slide, but still I want
can
answer
it be
from.
said like that? Mean and variance and autocorrelation are constant over a period of time, sir.
Okay. Right, that is technically correct. But I will show you with numbers what actually this definition means. It is clearly written that a stochastic process is said to be stationary if its mean, variance are constant over time, and the value of covariance between two time periods depends only on the distance or gap or lag between the two time periods and not on the actual time at which the covariance is computed. It sounds little heavy, I know. I will break it down and I will come back to it again and connect the dots. In short, we can say a time series, if a time series is stationary, its mean variance and auto covariance at various lags will be time invariant. That means they will be constant, right? And such time series will tend to return to mean. They will be mean reverting in nature, right? They will be mean reverting in nature. And fluctuation around this mean will have broadly the same, spread, that is constant variance. So they will be, even though they deviate from the mean, they will tend to revert to the mean. They will be mean reverting in nature. A stationary, time series will be mean reverting in nature. And the fluctuation around the mean, that spread, should be constant, right? So to put it differently, a stationary process will not drift too far away from its mean value because of the finite variance, right? Now, these are the things we have studied, those who have studied time series before, but really we do not, have very good mastery over these things. So, and you will never have that mastery unless you actually, work on a data and cross verify that these things are happening, right? So I will do that now, and then again I will come back to this slide and try and connect the dots. So now let us do the first little. Now we will do the first little, practical work with a data set. Okay, fine. So let us start. I will first do it in Excel, so the calculation, and then we will do it in R, because that will help everyone understand, help in understanding the calculations very clearly. Okay. So are you ready? We start? Yes or no? So let me go to the data set, and I will show you what all are the properties of a stochastic process which is stationary in nature. Okay. So we will work on this data. We'll work on this data. Which data we will work on? We will work on Excel test demo data. Okay. And then we will also work on this in R. Okay. So for now, you can just observe what I'm doing, right? And when we will do it in R, that time you can do it alongside me. Okay. Is that okay with all of you? Yes or no? Because I need to explain the concepts very well and step by step so that everyone can understand. Okay.
Sir, are you sharing this data, sir, actually?
I have not yet shared. I will share it.
Okay, sir. Okay, sir. Okay.
I will
Thank
share
you.
it. Do not worry about it. I will share the data. Everything will be shared when we will be doing it in R.
Okay, right. Thank you. Thank you.
Please understand this concept, because this is the most important concept in time series, the understanding the concept of stationarity. So everyone is saying that stationarity means mean is constant, variance is constant, auto covariance or autocorrelation is also time invariant, right? Now let us break it down step by step and try and understand what actually those properties mean, right? So suppose I have these these variables. This is the data set I have. This is the data set I have. That means I have 200 data points collected over 200 points in time, right? And I have termed this variable as y subscript t. It could be any variable for that matter, right? So these are given to me. These are given to me, right? These are given to me. Now, what I have done, I'm trying to verify the properties of stationarity to figure out whether yt is stationary in nature, whether yt is stationary in nature or not. Okay, this is what I'm trying to verify. Okay, so the very first thing that you can think about is to plot yt against time and check how does it look, right? To get an idea whether it is stationary or not. So let us do that first. Okay, I'll show everything in R. Do not worry about it. Just first take a look at this and how to approach this particular thing. That is very, very important. So if I just do the plotting, simple plot, if I make, so the plot looks like this. So what do you make out of it? Is it stationary? YT is stationary? Y subscript T, is it stationary from the plot? Yes. What is your answer? Is it stationary?
Yes.
It looks like stationary because the easiest thing that you can identify in a variable to decide whether it is stationary or not, to check whether it is mean reverting in nature or not. If I calculate mean and plot it, it will be somewhere in like this, right? Yes or no? Yes or no? If I calculate the mean and plot it, it will be somewhere, it will be like this, in between this.
Yes, sir.
Yes,
Right?
sir.
So you can
Yes.
say that the variable is deviating from mean, but it is reverting towards mean. Yes or no? So that is the easiest hint. We obviously have augmented Dickey-Fuller test and all to figure out whether statistically whether a variable is stationary or not. That I will cover in the next class. But the very first thing that we can do, we can just plot it and see whether the variable is mean reverting in nature or not. So from the first impression, it looks that YT is stationary in nature because from the plot it looks to be mean reverting in nature, right? And mean reversion is very, very important. I will cover this in greater detail when I will talk why do we emphasize on the fact that the time series must be stationary in nature and what all problems will it create if it is not stationary. That part I will cover later on. But for now, understand what is meant by mean reversion. That means the variable tends to revert to its mean. So that is called mean reversion. So if the variable is stationary, it will be mean reverting in nature. Okay, this is the first thing that I wanted you to understand. So this part is clear, I think. Okay, now, so we told that the variable, if it is stationary, its mean should be constant. It should be time invariant. It basically means the mean of YT should be more or less same as mean of YT plus 1, mean of YT plus 2, mean of YT plus 3. Okay, because mean should remain constant, right? It does not matter when, at what point in time you are calculating them, right? So how to do that? So what I'll do, this is suppose given to you, I'll create a new variable. I will create a new variable. What is the new variable that I will create? So I'll just let me delete this and show you the process, how this has to be created, right? We can always automate these things, but first of all, you need to understand how this calculation is done. Otherwise, never ever these concepts will be clear to you. So how can I make a new variable? How can I make a new variable with which is termed as y under subscript t plus 1 from YT? Anyone? How to make this? What will be the first observation? First observation will be this one.
Second
Yes
year.
or no? Yeah. Correct? Yes or no?
Yes, sir. Yes.
Clear.
Sir.
Understood, everyone, what I have done? Yes or no?
Yes, sir. Yes.
Okay. And this one should not be there because we have lost one number, right? Yes or no? Instead of starting from here, I have started from here. So the last number
Yes,
should
sir.
not be there. Correct?
Correct.
Now, if I want to calculate, create a new variable, that is y under or y at lab t plus 2, right? So how to do that? What will be the first number? Anyone? What will be the first number? What will be the first number? Equals to what will be the first number?
C2.
हाँ या C B4
और B3 वही है sir.
B3.
Yes, B3. B3 should be the first number. Yeah, correct. Right? Is it clear? Everyone understood? Now these last two numbers should not be there. Yes or no? Yes or no?
Yes sir, yes sir.
yes sir
Yes, sir.
Now, if I create another variable y subscript t plus 3, what will be the first number?
B5
This one, right? Yes or no?
B3.
Correct? Clear? Everyone understood? Yes or
Yes sir,
no?
yes sir.
Okay.
yes sir
So this is how we create. Last three we have to do. Okay. Now, what we can do? If you just now calculate the mean, I'll calculate mean of yt,
first series.
that is 100. Similarly, I calculate mean of y t plus 1, that is again 100. Then I calculate mean of, that is simple average of y t plus 2, that is again 100, and y underscore t plus 3, mean of that is almost 100. Okay, so if you round it to the nearest whole number, all are 100. So mean is constant. Yes or no? Yes or no?
Yes sir, yes sir.
Yes
Mean is
sir
constant. So what I can do next, we can calculate variance. We can calculate variance. How to calculate variance? Simple. In Excel, you can use var.h for sample, right? Variance calculation. I have calculated the variance for all of them, right? And do you see they are more or less same? They are more or less same. Yes or no? They are more or less same.
yes sir
Are you able to find that? And what will be SD? SD will be square root of variance, or you can use the stdev function also in Excel, stdev dot h for sample, right? And if you do that, SD numbers are also more or less same, because variance numbers are more or less same. So we can say that the mean and variance are time invariant, more or less time invariant for this particular variable. Can we say that? Yes or no? Can we say that?
Yes, sir.
Yes.
Yes.
Yes. Now the third property, which is the most confusing one. The third property says that the autocorrelation or autocovariance. We will first talk about autocovariance. Autocorrelation I will introduce later, because though it is similar concept, because you know that how covariance and correlation are related. Anyone? Those who are from econometrics background or economics background, those who have studied, most of us have studied this before. How covariance and correlation are related.
Sir, correlation is it the standardized version of covariance? Because correlation reduces the value between I guess -1 and +1. So
Yeah.
covariance is a large number. So standardized version of covariance actually is correlation. That's my understanding actually.
Yes, you are absolutely right. And what is the problem with covariance? Covariance can range from -infinity to +infinity, right?
Yes, 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 sir, yes.
Yes or no? Both correlation and covariance are measure of co-movements. But it is very difficult to interpret covariance number, because it can range from -infinity to +infinity. So what we do? If we divide, suppose I am calculating correlation between x and y. So first we'll calculate covariance between x and y, and then divide it by the product of standard deviation of x into standard deviation of y, right? So this is called a scaled measure of co-movement, and the correlation ranges from -1 to +1. And correlation is easy to interpret. Okay, so correlation is a measure which is easier to interpret because it lies in between -1 to +1. So if it is +1, then we say perfectly positively correlated. If it is -1, we say perfectly negatively correlated, right? So, but with covariance, it is very, very difficult, right? But we will get into correlation later on. First, we will calculate covariance as the definition says covariance, right? So instead of writing covariance, I have written auto covariance. Can anyone tell why have I written auto covariance? Anyone? Why have I written auto covariance? Why not only covariance? What is so fascinating about auto coding? What auto term here? Anyone? Why is it called auto?
Sir, because it is based on the lag values that we are talking about the impact of previous values, so we call it as auto covariance.
So covariance measures the co-movement between two variables. But here the two variables, say for example, if I calculate auto covariance at lag 1, it means what? I am calculating covariance between yt and yt plus 1, right? Yes or no?
Yes,
Yes
sir.
or no? So auto means self. So yt and yt minus 1, they are what? The, yt is the lagged value of yt plus 1. Yes or no? Correct? So I am calculating, if I am calculating the covariance between x and y, then I will use the term covariance. But if I calculate covariance of y with its lag value, then I have to use the term auto because the variable is not different. It is the same variable, but I am calculating the covariance between current values with the previous values or lagged values. That is why the term auto covariance is used. I hope this is clear to everyone. Yes or no? Everyone is clear about it? Now, how to calculate this? Simple. I will use covariance formula. I will use covariance formula, right? I will use covariance formula, right? So covariance function, covariance dot s. Let me do it once so that you understand what I'm talking about. So covar dot s, right? So I'll do it. I'll select this, Control Shift down arrow, right? But you see, I have to do the calculation between yt and yt plus 1, right? So, and for number of observation must be same to calculate this. So I will reduce this by 1. So I'll make it 200, comma, and I will go up and select this, right? And I will just enter. Okay, everyone understood what I did? Yes or no? Yes or no?
Yes, sir.
Yes, sir.
If I want to calculate auto covariance at lag 2, how do I go about it? Let me show it to you. Covar, right? So I will take these, Control Shift down arrow. Now I'll have to reduce this by two numbers, right? Yes or no?
199. Yeah.
Yeah. 199, comma. I'll take now this 3, right? Okay. Understood? Yes or no? Understood?
Yes, sir.
Okay. So similarly, we can do the auto covariance calculation at lag 3 that I am not showing. You have understood the idea, right? How to go about it. Now look at this number. We were telling that auto covariance should be same. Auto covariance should be same at different lag, but they are not same. At lag 1, it is 9.95. At lag 2, it is 0.62. At lag 3, it is 0.475. Now, is there anything wrong with that definition of stationarity? Auto covariance is changing with lag. Auto covariance is changing with lag, right? And they are not slightly different, they are significantly different. If instead of 0.95, if I get 0.94, it's okay, more or less same. But instead of 0.95, if I get 0.62, if I get 0.47, they are significantly different. So, is there any problem with that definition, or is there any problem with the understanding of that definition? The problem is in understanding of the definition. What it says is autocorrelation or autocovariance is time invariant, provided you are using the same lag, right? That means if you calculate, see, what is this? This is basically autocovariance between yt and yt plus 1. If you calculate autocovariance between yt plus 1 and yt plus 2, it should be more or less same. Similarly, if you calculate autocovariance between yt plus 2 and yt plus 3, it should also be more or less same, because the difference, the lag is same, because the lag is 1, right? Are you getting what I'm saying? Yes or no?
Yes,
Sir,
sir.
yes, sir.
Yes, sir. Yes, sir.
But at different lag lengths, autocorrelation will be different. And it is quite logical. See, what is autocorrelation? If I say, suppose I have daily data, I'm saying that at lag 1, means today's value and lag last day's values, we have computed two series, created two series and calculated the covariance. This covariance is expected to be higher than, instead of that, if I use 5-day lag, today's value and last 5 days value at the last past 5th day, right? Okay, at lag phase, create two series and calculate the covariance. Covariance is expected to be different. Yes or no? If I use the lag 1, covariance is expected to be higher. If I use lag 5, covariance is expected to be lower. Yes or no? Apply common sense. Yes or no? Is this point clear?
Yes, sir. Yes, sir.
Yes, sir.
Because lag is getting higher now, sir. Obviously, variance.
Yeah. So that is what was told, that it does not depend on at what point in time you are calculating autocovariance. It depends on the lag length between the two variables for which you are calculating the autocovariance. So that is why, to prove that point, what I have done, so this is autocovariance between yt and yt plus 1. I have calculated autocovariance between yt plus 1 and yt plus 2. So what is the lag length difference between these two variables? 1.
One.
So this
One.
should be more or less same with this. Is this point clear with everyone? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Similarly, if I calculate autocovariance between yt plus 2 and yt plus 3, here also the lag difference is 1. It should also be more or less same. Okay? Is this clear? Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Because the lag difference is 1. This is what they mean in the definition. But most of the times we do not understand it and misinterpret it. Okay? Now, if I calculate autocovariance between yt plus 1 and yt plus 3, it should be equal to what? Autocovariance at lag 2. Because what is the lag difference between these two variables? 2.
Yeah.
Or no? Have you understood now what is made by the same time invariant autocovariance? So if the lag length is same, then the autocovariance should be more or less same. If lag length is different, autocovariance has to be different. That is common sense. That means today's value and yesterday's values are likely to be highly correlated. But today's value and the value that occurred 5 days ago, they are less likely to be highly correlated, right? So the covariance is going to be different depending upon the lag length. But if they are measured at same lag length at different point in time, they should be more or less same. Is that point clear to everyone? Yes or no?
Yes, sir.
Have you understood? Everyone understood this point? Yes?
Yes, sir. Yes, sir.
Yes. So how many of you did not know this before? Tell me honestly, that this is how the definition is to be interpreted. most of us are little confused and we do not get into these minute details. We generally read the definition, all are constant, right? Mean is constant, variance is constant, everything is constant, right? So when we talk about auto covariance, we are talking about at a particular lag length, irrespective of when you are measuring the auto covariance, it has to be more or less same. But at different lag length, auto covariance has to be different because that is common sense. The covariance between today's value and yesterday's value is likely to be higher than the covariance between today's value and the value that we observed 10 days ago, right? If we calculate at lag 10, then the covariance is going to be different, right? Is it clear? Understood?
Yes,
So
sir.
if I ask you a question, assuming that this series is stationary, if I calculate covariance, auto covariance between y10 and y, that means yt plus 10 or t plus 10 and yt plus 12, what that auto correlation should be or auto covariance should be?
Point
I
six
repeat,
two.
Autocognition is black.
0.62.
0.62.
0.62
Yes, sir.
in and around 0.62 if this series is stationary, right?
Yes, yes, sir.
Because in that case, the lag difference is how much? 2, right? Is it clear?
Yes, sir. Yes, sir.
So that's the point I'm trying to make. Suppose you have 10,000 observations. If you calculate the auto covariance and the series is stationary, if you calculate auto covariance between y t plus 100 and y t plus 103, what should be that auto covariance?
0.475.
0.475. Exactly. This is the point that you need to understand. Is it clear? Everyone understood this? Yes or no? Yes or no? Yes or no?
Yes, sir. Yes.
Is
Sir.
it clear? So
Yes.
this is the precise definition of the stationarity. Now I will go back. I'll go back to the slide and reread the definition. Reread the definition. It will now make much more sense, right? It will now make much more sense, right? So let me go back to the definition again. And so what is stationarity? What does the definition say? A process is said to be stationary if its mean, variance are constant over time and the value of covariance between two time periods depends only on the distance or gap or the lag between the two time periods and not on the actual time at which the covariance is computed. Are you now able to understand what they are trying to say? Yes or no? Yes,
Yes, sir.
or no? Yeah, you got the point, right? So in short, a time series is stationary if its mean, variance, and auto covariance at various lags remain the same no matter at what point in time we measure them. That is, they are time invariant. This is where the confusion comes. Now I think you should not have that confusion, right? So covariance measured at lag 1 is likely to be the same irrespective of the time point when you are measuring. That is what I am saying. Yt and yt plus 1 auto covariance should be same as yt 100 and yt 100 plus 1, right? So that's the meaning. I think that point is now loud and clear.
Sir, in short, if since it is written, if a time series stationary, it mean and variance and auto covariance at various lags, it would be same lag.
No, various lag in a sense. So at lag 1, at lag 2, at lag 3, right? Measured at different point in time will be the same. That's what they are trying to make.
Okay. Understood, sir. Understood.
So this is confusing unless you work it on real data and verify, right?
Yes, sir.
Because otherwise we'll tend to think that auto correlation at lag 1, auto correlation at lag 2, and auto correlation at lag 3 all will be same. No. It cannot be the same.
Depends the distance or the gap or the actual lag.
Yeah, it depends on the distance. If the distance is same at different points of time, they will be same. That is what they are saying.
Okay, so understood, sir.
They are saying they are time invariant.
Yes,
right?
sir. Yes, sir. Yes, sir.
No matter at what point in time. Correct? Is this confusion clear? Everyone is now clear about this concept? Yes or no?
Yes, sir.
Yes, sir.
Yeah. Okay, good. So now you have understood this. And then the next part is pretty simple, that it must be mean reverting in nature, right? Okay. Why it is mean reverting in nature? Because the variation around the mean, the spread of that variation is constant, right? Okay. So if the variable is stationary, it will deviate from the mean, but it will not deviate too far, right? So that these are the things. Okay. Now you might go one step ahead and check. Suppose if someone says that, sir, if I break this into two subsets, we have 200 data points. If we calculate, if we make two data points, two subsample with 100 data points in one sample and another 100 data points in another sample, there also all these conditions should match. There also all these conditions should match. That means mean should be same. This is what I have shown. I'll just show it to you. Mean should be same, variance should be same, and this property should also hold good. But in real world, what happens? Most of the times, we are not able to meet these auto covariance assumptions, right? Most of the times. Okay. So, but is that a problem? Because I will just show you when we will do the subsample analysis, though we are kind of able to meet the mean and variance assumptions that they are constant over time, but the auto covariance part at times we are not able to meet. But is that a problem? Because the third conditions are not being met. Is that a problem? You might say, yes, that should be a problem. But it won't be a problem if your variable is normally distributed. Can anyone tell me why? That means even if you are not able to meet the third condition, and if your variable is normally distributed, still you are okay. Your results will not be considered spurious. That means you are able to meet the mean condition, that is mean is stable, constant, variance is stable, constant, but you are not able to meet the auto covariance related assumptions, right? So will that be a problem? But your variable is normally distributed. I'm saying that won't be a problem if your variable is normally distributed, because a normal distribution is a parametric distribution and it is defined by only two parameters. What are those two parameters? Mean and variance. Mean and variance. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
So if your variable is normally distributed, even if you are not able to meet the auto covariance assumptions, it's still okay. No issues. You have to meet the mean and variance assumption. But I will go one step further. When in practical examples that or practical data sets, when we will work with real data sets, we may not be even able to meet the variance assumptions pi to pi, right? See, if you look at the plot that I showed, that variance, the spread was not exactly the same, right? Yes or no? There was variability, but most of the times we are able to, if we are able to meet the mean assumption, right? That is kind of okay to go ahead with, right? So variance, more or less, it should be stable, but heteroscedasticity is the order of the day. You know that, and in finance data, so obviously heteroscedasticity problem will be there, right? So to deal with that, we do some other adjustments, but mainly we look for mean stability, and we look for whether the variable is mean reverting in nature or not. So ultimately, it boils down to the mean reversion for all practical purposes to decide whether the variable is stationary or not. Is this point clear to everyone? Yes or no? Is it clear to everyone?
Yes,
Yes
sir.
or no?
Yes, sir.
So mean
Okay.
reversion, I didn't understand that point, sir. Mean reversion, what does it mean, sir?
Mean reversion means reversion means what? Returning to mean.
Returning to mean. Okay.
So that means even if it is deviating from mean for a short period of time, it
Oh, it
ultimately
is again coming back
reverts.
to the mean.
That is what it
Okay,
is.
okay, understood.
So,
Sir.
and that you can easily identify looking at the plot.
Yes, sir. Yes, sir. Understood.
So
Sir.
ultimately, for all practical purposes, if the variable is mean reverting, that is considered to be stationary.
Stationarity. Okay.
Okay. Because other assumptions are very difficult to meet. Right? Think logically.
Yes,
Other
sir,
assumptions are very difficult to meet.
Yes. Sir.
Okay. So I will show it to you. Now what I have done,
But sir, normally that graph comes when we make log. When we use
not
log.
necessarily. With suppose if you have percentage change data, so the rate of return you are plotting. There also without log transformation you can get that stationary.
That graph normally comes when we use gauge.
No, that is you might use guards and all. That is a different point. But what I'm saying, suppose say stock price. If you are trying to check whether stock price is stationary or not, it is obviously not stationary. But if you calculate whether the return on that particular stock is stationary or not, it is more likely to be stationary. Okay, that's what I mean.
Because normally graphs have trend.
Huh?
Normally graphs have trend.
Yes. Say stock price, GDP, they will have trade. All these things I will go into in much more detail. Just wait for some time. Okay. But first make it a point that you have understood these points that I have explained. This concept of stationarity is clear to everyone. Yes or no? Is it clear?
Yes, sir. Yes.
It's clear. Now I'll just quickly show you that if I do subsetting, I have made two subsets. One with first 100 observations, another with another 100 observations. And I have done the calculation. So you see, it is more or less looking like mean reverting in nature. Yes or no? Yes or no? Correct?
Yes, sir.
Mean reverting in nature. And we have computed these numbers, right? And you see, they are not necessarily very close. Some difference is there, right? Means are more or less close to each other. Variance and standard deviation, they are more or less close to each other. Here, there are slight differences, right? In the main sample, it was how much? 0.945 or something, right? Correct. So lag 2 is still fine. Lag 3 slightly different. So there are differences. And if you go for subset 2, you see means are more or less same, right? Variance are also close to each other, but slight difference is there. But in auto covariance numbers, they are not very close, right? Yes or no? That means I am talking about the auto covariance at lag 1 in main sample was how much? 0.94 something, right?
Yes, sir. 94.
So they are different.
Yes, sir.
So we are not able to meet that.
Yes.
We
Third
are not
assumption
able
is
to
not
meet
met.
the auto covariance assumptions, right?
Yes, sir.
Yeah. So that is what I'm telling, that in all practical purposes, we may not be able to meet the third and second condition many times. But as long as we are able to meet the mean reversion condition, that is good to go ahead with, right? And we'll have to make some other adjustments to ensure that the other problems are, given due consideration. So we will discuss that ROA standard error and all those things we have discussed earlier, right? And there are other means also. Okay. So is this point clear to everyone? Everyone understood up to this, right? So how to go about approaching the what do you call this stationarity issue? Is it clear? Please tell me honestly, have you understood this stationarity concept or not? Yes or no? Hello?
Yes, sir. I have understood, sir.
What about others? Everyone understood this stationarity concept?
Yes, sir. Yes.
Yeah. So now see, if you simply read the books, you may not be able to understand unless you work on some data and figure it out how it works. It is always little challenging, right? Okay. So now I think we can go to R and do the similar exercise quickly. just to introduce you to R, especially
Sir.
those who are. Yes.
Sir, is there any t plus 1, t minus 1 is one and the same, sir?
It is same thing.
Okay,
Right?
okay.
So as long as if I say it like this, that yt plus yt and covariance between yt and yt minus 1 should be same as covariance between yt and yt plus 1. Yes or no? Because lag difference is 1 only.
Yes, sir. Yes, sir.
Yeah, for a stationary series. So different
Thanks.
books, they use different ways.
Yes, sir. Yes.
But this is easier approach to create a new variable like this.
True,
Instead
sir.
of going
True.
backwards, you start with t, then t plus 1, t plus 3, t plus 4, like that. Okay.
True, sir. True, sir.
Understood. But conceptually they are same, right? And if the series is stationary, and as long as the lag length is same, it should not matter, right? Yeah.
Yes, sir. Yes.
Is it not? Is it not?
Yes,
So
sir.
it means what I'm trying to say, if I create a series yt minus 1, mean of that should be ideally same as yt, mean of yt, right? Yes. Yes or no? If this series
Yes,
is
sir. Yes,
stationary.
sir.
That's how it is. Okay. So you got the point, I think. Okay. Okay. Am I going fast? Everyone is able to understand this part. I wanted everyone to understand. Okay. I think it should be clear now. And now let us go to R and let us do it. Okay. I'll give you the data set that we will use for doing it, doing the calculation in R. Okay.
So isn't there any rule of thumb that all the assumptions need to be met?
No, that's what I told now.
Yes, sir. But
mean reversion is the main thing.
okay, sir.
Mean reversion is the main thing. Other assumptions in strict sense will. In fact, what we are talking about, this is weak stationarity. There is another version called, anyone knows, strict stationarity, wherein all the moments, not only mean and variance, skewness, kurtosis, everything should be time invariant, right? So
It's
that
not
will never ever be possible.
Yes, sir. It is
Right?
not possible.
Not possible. In this only we are not able to meet the third condition and second condition most of the time, right? So
Yes.
mean reversion is the reality. If that is at least can be ensured, then it's okay. We can manage with that. And if your variable is normally distributed, then with mean and variance, if those two conditions are met, that is more than enough, not an issue.
Yes, sir. Understood, sir.
Okay.
Yes, sir.
Okay, now what we'll do, we will work on R. So please, I hope everyone has installed R and R Studio. Those who are doing it for the first time, I had shared the link in the, there was one video tutorial in the group. Yes? Everyone has got R and R Studio installed? Yes or no? Especially those who are who have joined this workshop for the first time. Yeah?
So yes.
Yeah. Kajal and those who have joined, I hope you have at least installed R and R Studio.
Yes, sir.
If not, no problem. I will give the recording later on. You can just do it. But before the next class, please make it a point that you have done it. Huh? Okay. So that is the thing. Okay. Now let us. So please open your R Studio, everyone, and I will just share the data set with you, and we will do these similar things in R. Okay. And then we will proceed. But give me an honest feedback. Everyone has understood the concept of stationarity, right? Because this is the backbone of time series. Right? Okay. And I will teach you, or I should not say teach, I will discuss. I will discuss how to make a non-stationary series stationary. There are different ways of doing it. We only know differencing, right? We'll take first difference and we'll make it stationary. But many times, after taking first difference also, this variable may not be stationary. Then you say, sir, no problem, I will take second difference. But you know that for many econometric and time series model, if the variable is of difference twice, then it is not accepted, right? So you must learn how to make the non-stationary series a stationary one by one differencing. and doing something else, right? That is the trick. Okay, that we will discuss in great detail. Let us first do this R thing, then we will talk about the non-stationarity and how to convert a non-stationary series into stationary series. Okay, so let me give you the what do you call this? If I share it in the chat box, are you able to copy download it from there, or should I give it in the WhatsApp group? How is it going to be helpful? Right? Tell me.
Sir,
WhatsApp.
give it in the
Everyone,
WhatsApp group, sir. Because
and those who are joining, who have joined it for the first time, please during the session stay connected with the WhatsApp web. Okay, I frequently share the scripts and the data sets during the session in that group. Okay, so please do that. So this is the data set. I'll just give it in the group, WhatsApp group. So please take it from there. There is my WhatsApp group. Yeah. So applied time series. Okay, from here I left. So desktop, we will get into what is that? This is the okay. I've shared it. Fine. I've shared it. Everyone got it? Please download and save it onto your desktop, and please create a folder. Those who are doing it for the first time, please create a folder and name the folder as workshop time series. Like that, if you can use this naming convention, workshop underscore time series. Please do it. I'll give you a minute or so. Please download the dataset, create a folder in your desktop, name the folder as workshop underscore TS. TS stands for time series, or you can give any other name as per your choice, and save that dataset inside that folder. Please do it in next 1 minute, everyone. Please let me know once you are done with this. Okay. And is there anyone who is going to use R for the first time in life? Among these 16 members, is there anyone? Please do not hesitate to tell me if you are the person who is going to use R for the first time in your life. Then, because I need to tell you then certain things. That's why I'm asking. Is there anyone? Please do not hesitate if that is the case. No one? Everyone has used R before? If you don't say anything, I will assume that you have used it before.
sir, someone has written in the chat box, sir.
Someone has written in the chat box. Okay. Okay, yes, sir. I am first time using first time. But you have the R and R Studio installed, right? Okay, so there are few who have not used it before. No issues, so not a problem. I will just tell you from the very beginning how to use R. Okay. So, but at least make sure that you have done that. Created the folder and saved the dataset inside the folder. Is that done with everyone? Yes or no?
Yes, sir.
Yeah. And those who know R, little conversant with R, please bear with me because I'll have to just explain some very, very basic things for those who are using it for the first time. Okay. So please bear with me for that. Okay. So Okay, so in R we have something called script. We have something called scripts. So how to get to that? Those who are doing it for the first time, please follow me. Once you open R Studio, then you will get to see, there is a place, this is called console, where all your outputs will appear, right? And you have something called environment, where whatever you do, your, data and history, all these things are captured here. And there is a part where the visualization will be shown, right? Also, there is a part where you actually write the codes or scripts. And how to get to that script page? For that, you have to go to file. Please do it alongside me, those who are doing it for the first time. So go to file, go to new file, and then click on R script. Click on R script. Once you click on R script, a new page will come where you can write your codes. Where you can write your codes. Those who are doing it for the first time, are you able to do up to this? Go to file, new file, click on R script. A new page will open. Are you able to do it? Yes or no? Yes or no? Those who wrote for the first time, please answer. Are you able to do it?
They are writing in the chat box, sir.
Okay, they are writing in the chat box. Yes, sir. Yes, yes. Everyone is able to do it. Good, very good. You can use your microphone also now. I have not muted anyone, so you can tell. That is better instead of, because most of the times I won't be looking at the chat, right? Okay, ठीक है, कोई बात नहीं. It's okay. चले. Okay. Next, what is the next thing that I should do? Once you have opened that, then the next step is to do the, or next step is to set the working directory. How to set the working directory? I'll show you how to set the working directory. Go to session, click on session, then click on set working directory, then go to choose directory. Please do these steps, everyone, especially those who are doing it for the first time. And those who are doing, those who are veteran, for them also this step is must. First, you need to set your working directory. Go to session, then set working directory, then choose directory. Okay. Once you click on choose directory, then I told you to save the folder, create a folder in your workshop, in your desktop, sorry. And the name of the folder, in my case, workshop underscore ts. So I'll select that and I'll click on open. So my working directory is set. I repeat, go to session, set working directory, then choose directory, then go to that folder, and I told you to save it in desktop, and then select that folder and click on open. Are you able to do it? Yes or no? Everyone? Yes or no?
Yes, sir.
Yeah. So once you do that, you will get this in your console. And this is the path of your directory. This is the path of your directory. This is the path of your directory. Okay. So your working directory is set. If you want to see the path of your working directory with the help of a code, then you can use what? Get WD. Get WD. Type get WD in your script. Type get WD. Once you start typing, this will automatically come. If it does not come, you write these two brackets. Get WD. Get WD. I'll show you again. Get WD. Right? So if you run this, it will also show you the path of your working directory. How to run a code? Once you write any code here, you can select that code and click on run, or you can put your cursor anywhere inside that code and click run. Both the ways it will work. Okay, are you able to do it, everyone? Yes or no?
Yes, sir.
Yeah, especially those who are working for the first time, I need answer from them. Are you able to do it? Get WD.
Yes, sir.
Yeah, okay, good. So this is not a must, but this is for your confirmation that your whatever they are showing, that is the path for your working directory. Okay, next step is to install and load the package. I want to bring the data set into my R environment so that I can work on R. So on that particular data set. So what I'll do, I'll first install a package called read Excel. So to read Excel file and CSV file, you need a package that is called read Excel package. If it is installed in your system already, then you need not install it. You'll have to just call it. But I am assuming that it is not installed in your library. So first you install. How to install any package in R? Very simple. You have to type install. Once you start typing, this will come. Once this comes, you press tab. So the whole thing will come. You no need to type the whole thing. Install.packages, then open bracket, within bracket, double quote. And within double quote, you have to write the name of the package. The name of the package is read Excel. Name of the package is read Excel. Are you able to follow me? Install.packages, within bracket, double quote. Within double quote, you have to write the name of the package. The name of the package is read Excel. This package is used to read Excel and CSV data. Are you able to do it? And then you can just run this code. Please run this code. Just select this code or just place your cursor somewhere in between the code and click on run. Please do that. Please click on run. Have you done it? Once you do it, let me do it for everyone. Okay. So once you start, this, it will start downloading, right? So are you able to install, everyone? Yes or no?
Yes, sir.
Yeah.
Yes, sir.
And then once
Yes.
this is installed, the next thing that you need to do is you need to call that package. To call that package, what does this basically mean? It is like I told earlier also, if in your garage, you might have 10 cars lined up. But today you will decided that I will be driving my fifth car. So that fifth car now has to come in front so that you can drive. It's like that. So in R, you might have installed several packages over your working hours or over the time. But if you want to use a particular package, you have to call that package. So first you have to install, and after installation, you have to call that package. And how do you do that? For that, you use this command, library within bracket, read Excel. But do not use the double quote now. This is the practice that you have to follow. What I mean to say, library within bracket, read Excel. Library, read Excel. Okay, done. Library, read Excel. So just run this code. Okay. Are you able to do it? Yes, those who are doing it for the
Yes,
first time.
sir.
Yeah.
Yes, sir.
Yeah. Now, one more thing that you need to know, you might be wondering, sir, there are certain things written with hash symbol. What are they? So in R script, we generally differentiate between a code and a comment. So anything that is written after this hash symbol is a comment. It's a comment. It's not a code. What I mean by this, that means even if you select a code and a comment or a comment, a code or a comment. So look at my selection. I have selected a portion which is a comment, that is installed and load package. This is a comment. It's not a code. But install dot packages within bracket read Excel, this is a code. But if you select both the things, and click on run, R will run only the code, not the comment. Is this point clear to everyone? Provided you have given this hash symbol, and you see the color is different now. Once you give hash symbol, this color changes to this. Are you able to observe the difference that I'm talking about? Yes or no? Hello? Those who are doing it for the first time, for them I am repeating again and again.
Yes, sir.
So, and it's a good practice to write your own comment so that later on, whenever you look at the code, you understand what you have done, right? Okay. So I hope up to this it's clear. Now it is our time to load the data. So I have given the comment, load the data with a hash symbol. To load the data, what you have to do? Follow me. Data is equal to the data that I have shared. Is it a CSV file or Excel file? It is a CSV file, right? Yes or no?
Yes, sir.
So for that, the command is or function is read.csv. Once I start typing, it comes read.csv. Press tab, read.csv. Within bracket, double quote. And within double quote, place your cursor. I repeat, data is equal to read.csv, open bracket, within bracket, place your cursor and hit tab. Once you hit tab, it will show you all the files that you have kept in your working directory. So it is showing me all the files that I have kept in my working directory. And this is why you must create your working directory first before you start doing any scripting in R. I repeat, data equals to read.csv. This is the function for loading the data. Open bracket, within bracket, double quote. Within double quote, place your cursor and hit tab. Once you hit tab, it will show you all your files in your working directory. Out of these, I need this file, right? ssp.csv. So you go to that. Let me select that and hit tab again. It will come. Are you able to do it? Yes or no?
Yes, sir.
Yeah. Okay, good. So once you have done this, then what you have to do, you just have to run this. How to run? You can select the whole thing or put your cursor in between the code anywhere and click on run. Once you click on run, the data will come in the environment, R environment. Are you able to find your data in the R environment? Those who are doing it for the first time, yes or no? Are you able to
Yes,
find
sir.
your correct?
Yes,
Now,
sir.
if you want to see the data, you just click on this data anywhere here. It will just click here. It will show you the data. So what you have time and you have y. These are the two variables you have. One is time, one is y. Correct? Is it clear? Are you able to see this data, everyone?
Yes, sir.
Okay, very good. Fine. So now what we are going to do, we have got the data in our environment. First thing that I will do, I will extract the variable y and name it as y. Okay. So see what I have written. Extract the y variable. So what I'm doing, y, this less than and hyphen is doing the same work as equal to. Instead of this, you can also write equal to. So y equals to data $sign y. What does this mean? I am extracting only variable y within the data. My data set is named as data. Within data, I have two variables. One is time, the other one is y. I am extracting y. This is what it basically means. Okay. Everyone is able to do this? Yes or no? Please do it quickly, everyone. So just run. Once you run, it shows you y. It's a numeric variable, and there are 200 points, data points, 1 to 200, starting from these numbers. Okay. Are you able to get it? Yes or no?
Yes,
Yes,
sir.
sir.
Next, extract the time variable. Extract the time variable. Same process. I have named it time. This is your own name, whatever name you want to give. So time, then you can give equal sign. Again, data, $sign, time. That means you want to extract time out of the data. Okay, please do it. So now I have time and y, both. Why I extracted y and time separately? Because I want to plot them. I want to plot them. Are you able to do up to this? Yes or no?
Yes, sir.
Able to extract y and time? Those who are doing it for the first time, yes or no? Now what I'll do, I'll give this code in the group, or let me try it in the chat box. If I give, can you copy and paste it from here? Yes? Yes or no?
Yes, sir.
Can I give it in the chat box? Please try. If this works, it is better, because every time did not go to. I have given the code in the chat. Okay. You can just copy this code and paste in your R script. Okay, because it's a lengthy one. I will explain what does this code mean.
Sir, could you give in WhatsApp, sir, please?
So which one is comfortable for all of you? Tell me, I'll do that.
Because
Doctor,
WhatsApp, we can try it later also. That's it.
okay. So correct. That is true. Because that that will be there with you, right? Yeah, in the WhatsApp group. So I'll put it in the WhatsApp group only. Okay. So in the WhatsApp group, I'll put it. So just copy it and copy and paste in your script, because it's a lengthy one. I'll just tell you what this code is all about. Okay. Yes. And those who are doing it for the first time, are you able to copy and paste? Yes or no?
Yes, sir.
After copying and pasting, select the code, or put your cursor anywhere in between the code and click on run. Are you able to see a plot comes under the visualization part?
Yes, sir.
Now, so is it mean reverting in nature? from the plot? What do you make out?
Yes, sir.
Yes, sir. It is
It
mean
means
reverting, sir.
mean reverting in nature. Now let me explain you this code. What is this code all about? What we are basically doing? So we are doing a very simple thing. I am plotting time and y. What is the type of the plot? Line chart. Type is equal to L means line chart. What is the color of the plot? Blue. What is the width? So if I make it instead of 3, if I make it 4, what will happen? Can you see this width increased? Yes or no? It become thicker, right? Yes or no?
Yes, sir.
Okay. So if I make it 2 again, so it will go back to what it was originally. If someone likes red, because you cannot rule out red also, na? So if someone likes red, so you can change the color to red. The color will change, right? Or any color of your choice you can give, right? So I'll stick to blue, right? What is there in x-axis? Time. What is there in y-axis? X lab time, y lab is y. And what is the name of your plot? Time series plot of y. You can give any name of your choice, right? Time series plot of y. Have you understood what is this code all about? Yes or no? But I will strongly recommend for lengthy codes, it is always better to do copy and pasting. And codes are easily available. You can ask ChatGPT, Gemini. Codes are easily available, so not a problem at all. And if you cannot manage it, you can always get in touch with me. I will always give you the codes, not a problem at all. Okay. So is it clear? But once you get the code, try and make some sense out of it. What is happening? That's the most important thing. There is no point memorizing it because you cannot memorize all the codes. These are lengthy codes. So that's not the point, but you should be able to understand what is going on. Is it clear? Understood everyone the code for plotting? Yes or no? Hello.
Sir, what does this type equal to I
I
mean?
equal to line chart. Line chart.
Okay,
L means
sir.
line chart. Okay.
Okay, thank you, sir.
Okay. Now we by default we use line chart only. Right? Next. Now what I'll do, I'll just do those calculations, calculate mean, variance, SD, and all those things, right? For the main variable. Okay. So I'll just give you these codes in the group. These are simple calculations. We have already done these calculations in Excel. I'll just do it in R. Quickly we'll do it. So I'll put it in the group. Just now you can pick up speed, copy and paste faster. Okay, so I'll calculate what is the mean of, let me run the codes and then I will tell you what it is. So once you run the first code, mean of YT is equal to 100.0025. 215. This is what we got in Excel also, right? And look at this code, what I have done. Function is mean. You want mean of what? Y in bracket. And this name is your choice. You can give any name. This is your choice. And this symbol is doing the same work as equal sign. You can also use equal sign. Okay. Everyone is able to do it. Similarly, you calculate variance. So what is the function? VAR. R within bracket Y. That means you want the variance of Y. Okay. Run this. Once you run this, you will get this. Variance of Y is 1.489. This is what we got. Similarly, we have computed standard deviation. So SD, function is SD of Y. Right. Run this. Okay, are you able to get everyone these numbers? Yes or no?
Yes, sir.
Yes, sir.
Now, I want to do the similar thing for yt plus 1, right? We want to calculate mean, variance, and standard deviation for yt plus 1. So these are the codes I'll give you, and then I will explain what is going on in this code. So just quickly do it, and then these are very easy stuff, but someone who is doing for the first time, even this can be a little challenging. So we'll go slow, not to worry about it. Next class, we'll do it faster. Okay, I've given you the codes. And the good thing is, see, against every code, I have given the comment so that you understand what is going on when you refer to them later on. So first one is, I want to calculate, see, this is again my own name. You can give any name. I have written like this, mean underscore yt underscore plus 1, right? So basically, I am calculating mean of yt plus 1. Now look at here. Mean as usual, as used before, in bracket y. But you have to specify that you exclude the first observation. You remember when we computed created a new series, new variable yt plus 1, we started from the second observation of yt, yes or no?
We removed the first observation.
We removed the first observation.
Yes, sir.
We excluded. So that is what you are asking R to do. There we do it manually. Here R will do it for you. So what is the instruction you are giving? I want to calculate mean of y, but you exclude the first observation. So in bracket -1. This is what it means. So it is clearly written. Mean of yt plus 1 exclude first observation. Is it clear? Yes or no? Understood?
Yes, sir. Yes, sir.
Okay. The same way we'll calculate variance for yt plus 1. Same process. VAR in bracket y in bigger bracket -1. So same thing. Run. Similarly, you can do the SD also. Is it clear? Everyone got this? Yes or no? Same logic. Yes or no?
Yes, sir.
Yes, sir.
Those who are doing it the first time, are you able to follow me? Please do not hesitate. If you are struggling anywhere, we are always there to help. Yeah? Yes. Okay. Next. So now same thing, repetition. We will do same calculations for yt plus 2. So I'll just give you the codes, but here you have to be a little more careful. I'll explain that. So let us first do the clerical part. Okay. So let me run this and then I will tell what they mean. Now look at this code. This part you understand the naming convention. It is your choice, mean underscore yt underscore plus 2. Then this also you won't know, mean. I want to calculate mean of y. But in y, I want to exclude first two observations. Yes or no? Yes or no?
Yes, sir.
Okay. I want to exclude first two observations, right? So how do I write that? If it is only 1, so I can in bracket, I could have written -1. But since it is more than 1, so I'll have to create a vector like this, right? So minus means I want to exclude C. C is used to combine more than one thing, right? So 1 and 2. That means I'm telling drop first 2 observations and then you calculate mean of y. Is it clear to everyone? Yes or no? Understood?
Yes, understood, sir.
The same way you can do variance calculation, same way you can do standard deviation. Please do it, complete everyone. Have I run this code? I think I have. Yeah. Please complete everyone. These are very basics because this is first class. That's why I'm also not getting into too many complex things. But you have to start from somewhere, right? Always. So let us just quickly complete the last part, that is mean, variance and SD calculation for yt plus 3, right? So I'll just give you the codes here. Yes, those who are doing it for the first time, are you able to fetch the codes from the group? Yes or no? Hello.
Yes.
Now you see, so now I'll have to give instruction to exclude first 3 observations, 1, 2, 3. That is why minus C within bracket 1, 2, 3. Right? And you see that if you try to memorize, it is going to be really difficult. So there is no point trying to memorize. Because if you miss one bracket somewhere, one comma somewhere, say R will throw error. So in those cases, there is no point trying to memorize things. So, but broadly, you understand what the code is all about, and you have to take help from external source, and it is easy to get the codes, not a problem. Okay. So let me just quickly run these codes and so that you can. So you got the basic idea how to go about it, right? Okay, have you done up to this? Everyone could do it. Yes or no? Hello.
Yes. Yes, sir. Yes, sir.
Yeah. Now we'll calculate the auto covariance at lag 1, lag 2, and lag 3. Okay. So let us do one by one so that everyone can understand what is going on. So first we'll calculate auto covariance at lag 1. So I'll give you the code and explain it to you. So I have given the code. Let me run the code and then I will explain what is going on. Have you executed the command?
Yes, sir.
Now just pay attention what is going on. And now you will appreciate why I showed this calculation in Excel earlier. Because without doing it in Excel, if you simply look at the code, you will go mad, right? See, auto covariance underscore lag 1. This is my name. You can give any name of your choice. Just so you know equal sign or the sign, whichever way you assignment sign. COV for covariance. This is the function. Covariance between Y. But in case of Y, you remember, I removed the last number. Yes or no? It was 201. I made it 200. Do you recall when I did it in Excel?
Yes, sir. In order to have the similar observation, you have
Same
to.
number of observation. Yes, same number of observation. And for the other thing, that is yt plus 1, I did not consider the first observation of yt, right? Yes or no?
Yes, sir. Yes, sir. I remember, sir.
So this part is representing what? Yt, and this part is representing what? Yt plus 1. And in yt plus 1, how do I get yt plus 1? By excluding the first observation of yt. Yes or no?
Yes, sir. Yes, sir. Remember, sir.
So in my data set, the name of the variable is y, correct? And
Yes.
that is nothing but my YT in my Excel sheet. Same thing.
Yes,
Correct?
sir.
Yeah. So this one, this adjustment is for excluding the last observation of Y, and this one is for excluding the first observation of Y. This one is representing YT. This one is representing YT plus 1. Okay. Everyone clear about it? And if you see the comment, it is saying covariance between YT and Y underscore T plus 1. Is it clear? Everyone understood? Yes or no?
Yes, sir.
Yeah. Hello. Newcomers, first timers, are you able to follow me?
Yes, sir.
Yeah. And that is why now you would appreciate why I did the calculation in Excel first, because otherwise it is very difficult to understand the codes, right? What is going on, correct? So now we will do it, the calculation in lag 2. If I do the calculation in lag 2, let me give you the code. Let me give you the code. Okay. So once you get the code, copy and paste and then run and see what is going on. Now you have to instruct R to exclude last two values of YT, right? Yes or no?
Yes, sir.
So when we computed, this one, that YT plus YT and YT plus 2, then what I did, I dropped two observations from the first series, and for creating the YT plus 2, we excluded first two observations of YT series. Same thing we have done. So now it is not only one, right? So if I say minus length Y, that means it will drop the last observation. But since I have to drop two of the last observation, last and second last, so I'll have to write now C, combination of both, right? Is it clear? So minus length Y. So if I just give this is the last one and this is the second last one. Okay? Correct? Is it clear? Understood?
Yes, sir.
Are you able to understand? So this whole thing, so look at this whole thing. So this basically is representing the fact that I am instructing the R software to drop the last two observations. And this, so you know, this is instruction given for dropping the first two
First two.
observations.
Yes,
So,
first two observation.
so this part represents your YT, and this part represents your YT plus 2. Okay. I'm again saying there's no point memorizing it. You have to copy and paste, but you understand what is going on, right? Is it clear? Everyone understood?
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Yeah. Okay. So please run this. And in the same way, we'll do it for lag 3. Same way we'll do it for lag 3. Now you understand what is going on. Same process. Just quickly copy and paste and get it done. Okay. So now just run the code same way. So I'm basically asking to drop, last 3 for YT, and for YT plus 3, the first 3 from Y. Okay, same logic applies. And the code. Okay. Now, if you want to calculate up to this, everyone is able to complete. Yes or no? Hello.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Now we'll be also calculating the autocovariance between yt plus 1 and yt plus 2. Similarly, autocovariance between y t plus 2 and t plus 3, and autocovariance between yt plus 1 and yt plus 3. I'm just giving all 3 codes to you. And I think now you will understand. I will just explain once one of these codes, then you will understand easily what is going on. But don't get scared. For research purpose and all, codes are easily available. You have to take help of that. Don't try to memorize. Anyway, if you try, you cannot memorize it. Okay. So don't worry about it. So I think you can, if you look at the first code, let me just run it. So this part tells R, this part is representing yt plus 1, and this part is representing yt plus 2. So because I'm using the same variable y, but I'm instructing to exclude some of the last observations and also instructing to exclude some of the initial observation, right? That is what is being done with these codes. In the second case, I am trying to calculate the covariance between yt plus 2 and yt plus 3. So this part is representing yt plus 2, and this part is representing yt plus 3. Okay. So here the instruction is to exclude the numbers that are coming at the end, right? And this is to instruct exclusion for the initial number. Right? Same logic applies here as well. Okay, and you can verify these numbers are same as the numbers that we got in Excel, right? Okay. Is it
Yes,
clear?
sir.
Everyone understood?
Yes, sir. The numbers are same between like
Yeah,
X
yeah,
and
everything.
R. Yes, sir.
Excel. And you see, in Excel calculations are easier in terms of the, if you look at the length of the code, right? Because these are for simple calculation, R will require little more effort. But when things get complicated and automation is required, then it will become very, very efficient, right? In that case, in Excel, you have to use macros and all, right? But for simple calculations, it is little, codes are little lengthy. There are other ways of doing it, but we'll get into those things later when we'll do the, main research paper analysis and all those things with the help of other packages and all. But I just wanted to make the things very, very basic calculation. Okay. Now the next part is subsample analysis and all. I'll just give these codes to you. The basic same logic applies here also. So you can create two subsets. One subset for first 100 observation, another subset for second 100 observations. So you see this code. Subset 1, this is my name, you can give subsample 1 or any name, is equal to data. Within data, you are interested in Y from observation 1 to 100, first 100 data points. Subset 2 is data $Y 101 to 200, last 100 points. Are you able to understand what is being done? Okay. So let me give you this to you. You will be able to do it. So I'm now doing the subsample or subset analysis. Okay. Have you got the code? Yes or no?
Yes, sir. Yes, sir. We have got, sir.
Yeah. Please quickly run this.
Done, sir.
Done. Okay. Then if you want to calculate mean, variance and autocovariance, right, at different lags, I'm just giving all the codes in one go, right? So at lag 1, lag 2, lag 3, just quickly finish it because I want to cover one more topic other than these. So I'll just give the codes. Should I give all of them in one go or one by one? Which one will be easier for you? Because if I give too many codes, you might get lost in some in between, right? So let me do it step by step. So you have done the subsetting part, right? First one. So let us just take a look at mean and variance, right? Okay. These are easy codes. Mean and variance. So very simple. You are telling calculate mean of subset 1 because in subset 1 you have defined Y from 1 to 100. So it will calculate mean of these 100 Y observations, right? Similarly, this will calculate. Oh, I did not run this course. Okay. Everyone able to understand this code? What is being done here? Mean 1 basically is mean of subset 1. I have already defined what is my subset. Subset 1 is Y values from 1 to 100. Subset 2 is Y values from 101 to 200. Is it clear, everyone? Those who are doing it, yes or no? Hello.
Yes, sir. Done it, sir.
Done.
Yes, sir. Yes, sir.
Next, you do the calculation for variance. I have already given you the code. Same process. Variance for subset 1 and variance for subset 2.
Done, sir.
And then I am giving these 3 codes for autocovariance at 3 lags. Just quickly do it. Similar logic. And then we will go back to the PPT and complete one more important concept. Just quickly, everyone, run the codes and get it done. So autocovariance at lag 1 for subset 1, at lag 2 for subset 2, autocovariance for lag 2 for subset 1, for subset 2, And similarly, at lag 3 for subset 1 and subset 2. All the codes are executed. So this is how you can do it. But do not worry too much about it. I just wanted to make you understand that we can even do the same calculation with Excel also, right? And for this, it is not making much of difference. But for big lengthy calculations, difficult models, R will be much more efficient than Excel, because many things we cannot even do in Excel for econometrics. Okay, can you just quickly move back to the PPT and complete one more important concept? Yes or no? Hello?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Yeah, so let us go back to the PPT and let us complete one more important concept. And so stationarity you have understood. This is the important concept. Why stationarity in the stochastic process is important. Why is it important? Why do we always talk about stationarity? Why is it important? Anyone? This is a very, very important concept that you need to understand. Why stationarity is important?
So prediction will be better.
Prediction will be better. See, no, I always give this example in class when I teach. Suppose if someone comes late and 5 minutes late, I allow that student. Next day, someone comes at 7 minutes late, probably I will again allow it. Say after some days, someone comes after 1 minute late, I throw that person, out, or does not allow that person to get in. After a couple of days, someone comes 15 minutes late. That day my mood was good, I allowed that person. Someday, a person was just 30 seconds late, I did not allow that person to enter. So students say that, sir, your behavior is very, very unpredictable. Why my behavior is very, very unpredictable? Because I do not behave in the similar manner to similar stimuli, right? So in that case, when someone comes at 3 minutes late next class, that person is not sure whether that person will be allowed inside or not, because that will depend upon my mood. So my behavior is not stable in terms of whether a student should be allowed inside or outside, or should be thrown outside. Okay. So what I'm trying to make you understand, if a time series does not behave stably, you cannot predict that time series, because in every time sample that you have collected, its behavior, if it is different, then can you generalize that behavior in other future time frame? Answer is no.
No, sir.
So this is why stationarity is very, very important. If the variable is behaving in a stable manner, then that behavior can be generalized in future. But if you see that suppose you have a 10 years data, you divide that 10 years data into 4 samples of 2.5 years time frame. And if you find that in every 2.5 years, the behavior of the variable is different, then can you predict the next couple of years behavior based on past? Answer is no, because it is behaving differently in different parts of the sample in time frame. But if you find that in all of those sub samples the behavior is more or less stable, then that can be generalized for future prediction or forecasting. So this is the precise reason why, the basic reason why stationarity is so important. If the variable is behaving stably, then that behavior can be extrapolated to predict future. If it is not behaving stably, it is behaving differently in different quarter, then that sort of behavior is applicable only to that particular quarter. It cannot be generalized for future prediction. Is that point clear? Is this point clear to everyone? Yes or no? Why
Yes, sir.
stationarity
Yes, sir.
is important?
Yes, sir.
Very, very important. This is the primary reason. That means if the stationarity assumptions or variable is not stable, at least if it is not mean reverting, you cannot do the prediction. Think like this. If it is mean reverting, then it makes sense to do the prediction, because you know if it deviates little bit from the mean, ultimately it will come back to the mean. So that helps you predicting which way the variable is going to go. But if it is not mean reverting, then there is no check and balance. Now it can go anywhere, right? So can you really predict that? You cannot. Is this point making sense to you? Are you able to understand what I'm trying to say?
Yes, sir.
So if it is mean reverting, then it can be predicted. Or in more simpler terms, if it behaves stably, then that stability lets you predict the future. But if it behaves widely and in different manner in different time frame in past, you cannot predict future based on past, because there is no predictability. There is lots of uncertainty the way it behaved, right? Or it behaves. So that cannot be used for future prediction. And later on, I will also explain that if stationarity is not there, and if you run regression, you might get spurious results. So one thing is for forecasting purpose, prediction purpose, stationarity is important. The other purpose for which stationarity is important is to avoid spurious relationship. If you run, suppose you are working on two time series, which I will discuss in my next slide, where I will discuss this spurious regression in greater detail. You are working on two time series, data points series, and variables, time series based variables, and both of them are non-stationary. If you run regression, suppose x and y, these are the two non-stationary variables. If you run regression, you might find there is a significant relationship as per regression, but they may not be at all related. Say for example, if you suppose in Africa in last 10 years crime rate has increased, and last 10 years internet usage has also increased. So if you run regression between these two, you might get statistically significant relationship, because with time both of them have increased, but both of them are non-stationary in nature. So this relationship is spurious. This relationship is spurious because theoretically you cannot defend, right? Suppose increase in rainfall in what do you call Meghalaya over the years, and increase in internet usage. If you run regression, you might find a significant relationship between them, but theoretically they may not be at all related. This is a spurious regression because both of them are non-stationary in nature. Okay. So next class I will again discuss this spurious regression part in greater detail. But for now, keep in mind that stationarity is important for prediction purpose. This is the basic requirement for prediction purpose. And stationarity is also important to avoid spurious relationship.